Welcome everyone. In this video, I will be covering section 16.9, concepts of section 16.9, the divergence theorem. State the divergence theorem. Let E be a simple solid region and let S be the boundary surface of E given with positive outward orientation. Let F be a vector field whose component functions have continuous partial derivatives on an open region that contains E. Then double integral over S f dot ds, which is nothing but the surface integral or the flux integral, is triple integral over E div f dv. So whenever we have a closed surface, then we use the word outward and inward orientation. For an orientable surface which is not closed, we use the um, upward and downward normal. Usually that is the terminologies that we use. So it's positive outward orientation. So simple solid region, which is what we see on E, simple solid regions, what are they? They are regions bounded by closed surfaces such as ellipsoids or rectangular boxes. So it makes sense to say outward positive orientation. This theorem states that the total divergence of a vector field, which is the right hand side, in a solid region E equals the total flow across the boundary surface S, which is the left hand side of the theorem, which is the surface integral. This theorem also shows the relationship between a triple integral over a solid region and a surface integral over a surface. In what ways are the fundamental theorem for line integrals, which we have seen before, and Green's theorem, Stokes' theorem, and this divergence theorem similar? In what ways are these theorems similar? Fundamental theorem for line integrals, Green's theorem, Stokes' theorem, and the divergence theorem. If you state all of this, if you um, notice all the conclusions of the theorem, fundamental theorem for line integral states that integral over the boundary curve C, which is of del f dot dr, the gradient f dot dr is f at the final and f at the initial point. R of A is the initial point. Green's theorem states that integral over the boundary curve C, p dx plus q dy is double integral over the domain D, dou q over dou x minus dou p over dou y dA, where C is the boundary curve of the interior region D. Stokes' theorem, integral over C f dot dr is double integral over S curl f dot ds. The right hand side is a surface integral, left hand side is the line integral. And then what is the connection between C and S? C is the bounding curve of the surface S. What is curl F? It is del cross F. Divergence theorem, which is the theorem that we are seeing in this section, is double integral over S f dot ds, which is the surface integral, is triple integral over E div f dv. What is the connection between E and S? Now, E is the solid region and S is the bounding surface of the solid E. What is div f? Del dot f, the divergence of the vector field F. What do you notice in all of this? We notice that we are integrating a derivative. So if you look at the first one, integral of del f. Del includes f sub x, which are derivatives. So integrating a derivative. So integral and derivative are kind of inverse processes. So they get cancelled out. So you get the function f at the uh, terminal point minus f at the initial point. Green's theorem states that integral over the boundary and integral over the domain. So double integral over the domain. So if you look at the right hand side, you are integrating a derivative. So one integral and derivative kind of get cancelled out, and you get the integral over the boundary C, p dx plus q dy. Stokes' theorem is also a similar idea. If you look at the right hand side, you are integrating a derivative because curl f involves derivative. So you are integrating the derivative, they are inverse processes. So one integral and derivative cancel out. So you get integral over cf dot dr on the left hand side. The third one, same way, if you look at the right hand side, the last one, the divergence theorem, if you look at the right hand side, you have triple integral of div f. So if you take innermost integral and the div, they are integral and derivative because div f involves the derivative. So you are cancelling an integral and the derivative. So the left hand side becomes a double integral over. Yes. So it's kind of everything relates to what you did as fundamental theorem of calculus in calculus 1 class. Everything relates to that fundamental theorem of calculus. So in each theorem, we integrate a derivative over a region. And this integral is equal to an expression involving values of the original function only on the boundary. So that is the beauty of all these theorems that we have seen so far. So in this section, I have covered the following problems. I have shown these following problems in the videos for the section. So problem number 1, and problem number 5, problem number 7 and 11. Problem number 11, problem number 7, from the additional suggested problems. All these are done in the videos for section 16.9. Please refer to those. Please refer to the videos for section 16.9. Hope this video helps.